That doesn't look right. Hold on. Okay, looks like we're good. All right, welcome to iRevive After Hours. I got a lot of repairs on deck. I've spent the last probably 10 hours working on a touch bar computer, and it's something to deal with a data line on the solid state. I think we're gonna have to call it quits on that one. It's just not practical anymore. At this point, we're gonna have to do a board replacement. So let's get to stuff that is practical, because we fell behind. 10 hours really did put us behind. Today, I got myself here a liquid damage or a beer damage MacBook Pro. Let's pull up OBS and see what everything looks like. Set that information to the side. So let's see exactly what we're working with here. There is moisture still inside. Well, it looks like moisture. It's actually all dried up now. So I was told by the customer it was beer that spilt inside of here. Let's pull the board out and inspect to see what kind of damage we're dealing with. Alright, so we just need our T5 screwdriver so we can start removing everything. And this stuff is pretty much just congealed back into some syrup. So this will definitely need to be ultrasonic cleaned. And with rare cases like this, sometimes I contemplate just ultrasonic cleaning before even doing the repair. Set up OBS better so I can see our YouTube chat better. There we are. The amazing thing is, even though this had beer spilt into it, the LCIs are still not tripped. All the beer went around the board, or around the LCIs. But there is still a pretty good deal of syrup on here. This may be one of those cases where we're just going to have to end up cleaning the board first, but let's try to get as much photos as we can of any damage before we do any cleaning. And it looks like the keyboard backlight cable is burnt up. So it looks like that's some damage right there. I'm afraid to even put power into this one, just because the amount of syrup. In fact, is this conductive? Not immediately, at least not according to using continuity and just kind of poking a giant glob of syrup. Still don't want to take the risk. It looks like some of the beer was around the CPU. No bueno. The ultrasonic cleaner is making some really weird noises over there. Sounds like someone tapping on the door. Alright, so that's the last of all our connections that are on the logic board itself, so let's see what this looks like on the underside. So far so good, the underside looks okay. Let's see if we can adjust OBS to zoom in more on this. So, that is this camera here. I'll work with that. It's not going to be the best quality, but for what I need it to do, that looks okay. Okay, let's look on the underside of the board. And let's actually take a look at this underneath the microscope. Okay, so I haven't even tested out to see if my camera is in focus. In fact, actually, the camera's not even working. Let's see what's going on here. What is going on here? So what happens if we turn a camera off and back on again? Strange. Yeah, it's unplugged, but it's still detecting the camera's installed, or displaying an image. May have to just reset the camera. Oh, no. It's not even detecting the camera. Okay, there we are. We're back. Sweet. And to get you in focus. So this is the back side of the logic board. It looks like it got pretty tore up. And let's see what this one is. This should be a late 2015. Yeah, this is 8204924. Oh, let's pull up on the schematics and see exactly what that component is. So 8204924. And we can get rid of that from earlier. Interesting. Schematic didn't want to pull up. There we go. Just had a hiccup there for a moment. Alright, so this is the back side of our board here. And the component in question is a capacitor. Looks like for the backlight. PPV out SO, no, keyboard. So this is going to be for keyboard backlight. And that's what's underneath the microscope. That looks so gross. So what we're going to do is just replace all of this. Well, let's take some further inspection to see what else is going on here. In fact, actually, yeah, y'all can pardon me for a quick moment. I actually need to upload this information to their ticket, just in case I do end up cleaning the board. So if you use Repair Shopper, a really cool feature is if you have OBS or just your camera in general hooked up to your computer, you can take photos directly from Repair Shopper from your camera and upload it to Repair Shopper underneath the ticket of the client. It is very handy, makes documenting corrosion so much easier. Now the question is, can I take a photo while OBS is using this camera? It looks like I might be able to. Nope. Not at all. Thought we could. Maybe if we turn off from OBS, and bear with me for just one moment. Let me see if I can upload a photo. I just need to keep a document of this corrosion here. Nope. Okay, I take that back. So it doesn't like having OBS and OBS and Repair Shopper use the tickets at the exact same time. Okay. Let's see what else we have. The rest of this side of the board looks okay, so the majority of the damage is going to be around our JTAG connector, which really isn't important since we don't have a JTAG for our CPU, and then our backlight. A lot of that looks bad. In fact, it looks pretty burnt up. Let's find out if this even works. So we're just going to put our multimeter into resistance and see if this is shorted. Surprisingly, no. Still going to replace it, of course. It looks like garbage. Alright, let's take a look at the other side. Let's see what we got going on here. So we know that the ooh. That doesn't look good. And to make matters better, we don't carry replacement backlight connectors in stock. Might be able to steal one off of a donor board, but it's going to be just a little tricky. Alright, let's see. What is that pin that's sticking up? That pin is going to be not connected. Okay. That's fine. We can live with that. And the pin next to it looks important, though. That pin is, yes, that's going to be our PPV out SO keyboard backlight. So that looks like trash. Ooh, it's like disintegrated. Oh my god. So we could approach this to one or two ways to save backlight. We're probably gonna have to replace the actual backlight layer on the keyboard itself. But to save backlight, since this pin's completely destroyed, we may be able to just take just a pin only from another donor board, or we may be able to attempt to transfer this whole thing over. I think that's what we're gonna do. So this looks like trash. We're gonna remove that. Let's see, what else do we have going on here? So there's a little bit of corrosion right next to the battery terminal. And that's going to be our PPDCN G3 hot charger. So we may have an ISL issue. Maybe. Let's look around the CPU. That's the part that really worries me. And it looks like there is a little bit of beer on top of a coil that's next to our CPU. But it doesn't look like it's actually on our CPU. Or really touching anything else that's conductive. So this was connected to power, and the customer drove 3 hours to bring it to us. So by the time she got here, the liquid was already syrupy. So the damage has already been done as far as board-wise. Let's see what this takes as far as voltage and amperage. Is this going to turn on? I don't think we're going to kill anything, since the majority of the issue is going to be related to our keyboard backlight. Alright, so I got a green light here, and it's booting. Or at least, looks like it is. Yep, that's booting voltage. So the board's fine. So as far as the board goes, we have some cosmetic things we need to take care of. We're going to have to do a test on the battery circuit afterwards. Let's dive straight into taking care of this keyboard backlight. And we will need a donor board for this repair. Let me go grab one real quick. In fact, actually, I think the last repair I did was also 8204924. And this keyboard backlight area is still fine. So we're going to use this donor board here. First thing I want to remove is going to be that connection for the backlight. I don't know why this camera makes everything look blue. It's almost like the filter that they put in horror movies. You know how they have like that blue tone overlay, and then for like happy movies it's an orange overlay. Kind of what it looks like here is this is something either out of like a scary movie or a sad movie. I don't watch movies. I personally don't have enough time for movies anymore. I hardly have time for video games. And I love me some video games. I've been working on playing The Witcher 3 since 2015. I still haven't beaten it. It's just such a large game. It takes forever to finish. And where did my Dumont tweezers go? Here they are. This area looks pretty gross. Let's see what happens when we hit it with our tweezers and our quick rework station at the same time. Alright, so we're moving the ground just fine. Then let's wick up the rest of it. My good clippers ran away. It's not the cleanest I've seen a connection. In fact, our ground looks still a little gross. And I think it's just because there was so much gunk there, I couldn't really do anything. I want to have this all nice and tinned for when I'm able to attempt to replace that connection. Now, directly underneath it, this little square right here, that's part of our backlight circuit for the LCD itself. We're going to have to test that out to make sure that didn't get harmed in the process. That looks so much better. And then just for the hell of it, let's check and see if this is shorted over here on our EDP cable. Nope, that's perfectly fine. So the residue, the molasses buildup, we'll call it, doesn't look like it did any damage to that component. So this part of the board, I'd say we're okay. Let's take a look here at our charging. This capacitor right here. Okay, so this is our PPDCN G3 hot charger. And what I'm concerned for is Q7155, which is going to be on the other side of the board. That actually might be okay. Why aren't you flipping? Come on. Oh. Turned off my keyboard. So let's just get a quick measurement. On camera. And see if this has any interesting ratings. Nope. Looks good. Just looks gross. I think we're fine. I think a good chemical bath will fix that. So now let's address the rest of our backlight, our keyboard backlight. Look at this. This just exploded right here. This took a lot of alcohol. Go home, keyboard. You're drunk. So, without any further questions, I'd say this needs to get replaced. Man, that really does look very blue. I think what it is the mat underneath I'm using for preventing burnage to my desk. It's red, and so this is trying to offset the color or color match it. Let me change this. Let's see what happens when I change with the properties. I can't do anything. Okay, so I would actually have to add a filter. Let's see what happens. No, this doesn't look like anything. Okay, that was audio, that's why. Okay. Oh, let's see what happens when we play with the color key. Make it more red. Yeah? No, that's not what we want to do. Okay, that's neat though. Maybe I don't know anything about color keys. That's what it looks like here. Let's delete that. Chroma key? Does that have something to do with it? No. You. None of that. Alright, remove that. And one more filter. Other than, we're just wasting time after this. Color correction. How about that? Alright, so everything's super green and super blue. I don't even know what's going on there. Set that back to default. Okay. I don't know. It's just a pet peeve of mine. We'll leave the color alone, but it doesn't look like that. So let's start off by replacing this guy. So when ooh, man, that is fragrant. When I'm burning something that's as corroded as this component, I like to put solder on both ends just to kind of heat up everything. Okay, yeah, that worked just fine. Good enough for what we need. Alright, donor board. Let's see what you got. Your capacitor looks significantly much better. Come on, don't run away from me. Oh, that was embarrassing. Okay. Try that again. You can turn down the quick. We really don't need it that hot. Okay, let's check and see if these are all okay. So this is the area we're working on. We got these two resistors right here that go to the display port with a resistance of 11 kilo ohms. What about you? 3.01. It's weird. It says 3 kilo ohms. Just to compare to a good circuit, not a good board, but a good circuit. This one says about 10. That's closer to what we have. That one's 2.5. And being that they are, looks like in series, I'd say that's close enough. So we're just going to replace this entirely. And the thing that sucks is when it's this sugary as you heat up with the quick, it really does a good job crystallizing the residue. So I normally clean with isopropyl alcohol. Let me see if any acetone fixes this issue. Alright, to make my life easier, I'm just going to replace multiple components on here. I'm going to replace these two resistors. This diode right here looks a little suspicious, and while we're at it, we'll just go ahead and we'll replace the keyboard backlight driver. For that, we need to turn our temperature back up. Just got a text from the wife saying that she just made bread. It's the very first time in our relationship I've ever heard her talk about making bread. So I'm looking forward to that tonight. Look at this. See what I'm talking about with the syrup kind of just bubbling again? Because it's crystallizing. As we're just kind of boiling all the moisture out of it and turning it back into crystals. Oh yeah, I'm glad that we're replacing that. As I'm looking into looking further into this looks bad. And we could take a risk and see if those measurements were okay and do an ultrasonic cleaning and then put it all back together. But I'm really pressed for time. I spent way too much time on that A1706 2017, but I'm sure it's fixable. However, after 10 hours of working on it, and I've been talking on the Rossmann Discord for the majority of the day, trying to get some help, and great technicians too, not discrediting everyone. Everyone who's helped has been fantastic help. It just seems like that for running a business, it's not practical for me to spend any more time with it. So this one, we're just going to have to opt in for a full board replacement. See if the customer wants to move forward for that. It's a shame too, because it just seems like it's just the SSD has some sort of power signal that's not turning on. And I've tested just about every power signal on that one, and it was all reading fine. I just couldn't get it to work. Thing is, Apple wants to replace the logic board for this one for about $800. We're not that much. Apple wanted $500 just to look at it. Now, I won't give them too much beef, because with COVID-19 going on right now, I understand with all the Apple stores being closed, they are at their limits. But telling customers that they have to pay $500 just for you to look at their device, a lot of people aren't happy with that. Justifiably so. I've heard some people say that some repairs with Apple right now will take you anywhere from sorry, just focusing on this resistor, will take you anywhere from 2 days to 7 weeks. Now, this is just what I've heard from the grapevine. Here, that's mostly like 2 days to 2 week turnaround time, but I've been hearing that it's been about 2 weeks to 7 weeks. What was the last component? Oh, yeah, this diode. That's right. Change the orientation here. So the diode, we're going to need some heat to remove. So we're in South Carolina, and we're starting to see a little bit of normality again. As of yesterday, the governor just allowed restaurants to limit indoor seating, but it's been about 2.5 months now, and it's interesting just to see the adaptation that a lot of the local restaurants have made. A lot of people have just put up like marquees outside and been still just serving outside, like a picnic essentially. There we are. Good. If there's one thing that Greenville, really just South Carolina, is known for, it's the food. So we get a lot of people who visit here to try the food. That's kind of our economy, is food and bev. I lived in Charleston for about 4, almost 5 years, and that's all anyone ever did down there was drink and eat. And man, do they have good eateries and good drinkeries. But to completely take that away here in South Carolina where we're at, it's just strange. I personally started getting into gardening. And I've learned the 2 things in life, right, or 3 things, actually, the 3 things in life that make me happy. Number 1 will always be my wife. She works here. You'll see her on some streams. The second would be seeing a MacBook that was liquid damaged come back to life, have a fan spin. And now the third thing I'd say is watching a seedling turn into a plant. Because it's like, wow, I took care of that. Now I just need to wait 3 to 4 months before I can actually start harvesting those plants. It's been rather enjoyable. I think I'm just getting old. I think what's I've passed that point in my life to where I don't have as many friends as I used to. I have more acquaintances than friends. So I garden more. Okay, what's this? This looks like a diode. It is a diode. Let's compare this to our board we have here. Where did you come from? Let's see, we had a diode here. And then we had a diode right up there. Is that it? It is. Alright, so this diode blew away. See if we can figure out the orientation. Alright, so we got our line right there on the right side. I don't know if you could see that. And let's compare that over here. Yep, it's in the same orientation. Come on, little diode, go back to your home. There you are. See, was that so bad? Beautiful. Alright, I think that circuit's gonna look much better after a chemical bath. Now let's just compare this and make sure nothing else blew away since we did lose a diode. So, comparing it, we look safe. Yeah. Alright, well, let's see if we can transfer the plastic connection that was the backlight. So I won't be able to take my tweezers to this because it's just going to melt it. So I'm thinking I use a medium to low heat and maybe this tool right here. This is a good tool here for BGA removal. So I was just making sure I was actually live. I kid you not, I did an entire live repair yesterday. Live. And then when I went to go turn it off on YouTube, there's a giant go live button. When you're streaming, it says end stream. Mine still said go live. I did an entire repair just talking to myself. I mean, which is no different than now, but instead of talking to myself, I'm talking to an abyss that is the internet. I'm just evenly heating up both ends. Plastic doesn't look like it's melting, so that's a good sign. Solder looks like it's starting to melt. Yeah, the pins are pretty much melted. I just need to melt the ground connection here. There we are. Aha! Awesome! Never done that before. Cool. That worked. That's how we get our own connection. Our own JTAG connection. Now, if the connection here looked as bad as it did, the actual backlight's gonna look awful. Actually, I want to switch over to my micro pencil for this one. Let's see if we can touch up these ground pads with our micro pencil. Oh, yeah, that worked. Come on, buddy. There you are. Cool. So that's one side. Flip this over. Last pad's just giving me a little hard time. We're getting there though. Okay, there's that side. And one more pin. I had a feeling this one was going to be just a little tricky. Let's see if we can touch it up real fast with a normal iron. Nope, switch back over one more time. Come on, buddy. It's just a ground connection. I'm gonna cheat a little bit. I'm gonna heat up the ground area. Alright, that's all the pads just went back to their home. Let's see if we can touch these two back up. I don't know what... Oh, seriously, this microscope. It gets out of focus very easy on the camera side. Come on. Let's make sure that that's on there properly. Nope. I don't like that. Let's see if I can touch up just a tad bit more. There we are. Much better. Cool. And that is our first transplanted JTAG connector. Or I shouldn't even say JTAG, I really... it is a J connector. This one is for the Backlight keyboard specifically. Let's see what all it's going to take to replace this. Yeah, those pins look pretty bad. And looking at this, it looks like that we actually... If we were to replace the entire backlight, it almost looks like we would have to remove our battery. Because part of our battery is covering the backlight. Let's see if there's any other way around that. Thank you, donor board. You've been very helpful again today. Alright. Just to get an idea, how long have we been at? Oh, we're almost an hour into this one. Need to finish this one up soon so I can move on to the next one. Oh, yeah, no, that's bad. Yeah, that's pretty bad. So this is our backlight cable, or our backlight circuit. And it's just kind of hanging there. So I would say, in order for this one to be a successful backlight replacement or repair, we actually have to replace this part of the circuit. And we can do that, just not tonight. Yeah, we'll end up taking care of that tomorrow morning. Need to jump onto another board repair. So this one boots up. I'm gonna go ahead and throw it in the ultrasonic cleaner. And then we'll finish testing out the rest of it. So what I'm doing right now is there's some EMI shields that are covering the RAM and the Thunderbolt, just to make sure that the ultrasonic cleaner really gets in. Just removing those so that the bubbles, the fluid that's built up from the ultrasonic cleaner, will go underneath those chips. It's 11 o'clock. Man, time flew. So I'm putting this one in the ultrasonic cleaner. The ultrasonic cleaner is going to emit a frequency that may disturb this stream. Okay, let's see what the next one we have on deck is while that's cleaning. Alright, looks like we got another liquid damage MacBook Air. Okay, we're back. Just had to take care of talking to my lovely, my wife, right before I went ahead and dove into this repair. So, for this one, in fact, actually, let's start this out, because I'm probably going to have to edit this one. Hi, today we have ourselves here a MacBook Air. It's an A1466. This one specifically, we can't even see the board number because there's a warranty sticker. Someone has sold this logic board to a repair shop that has already replaced this, and it looks like that the customer spilled some water into it. So I've already taken the liberty of pulling the board out, and when I hooked it up to our power supply, the first thing I noticed is that it only gets 0.01 amps. And the second thing I noticed is that our JTAG connection and our SMC reset switch is got a lot of corrosion. Let's zoom in some more. So let's go ahead and take a look at what's going on here. Alright, so the JTAG connection looks pretty bad. Yeah, that looks bad. So we're going to just replace that, or not even replace, we're going to remove that. JTAG connection is not important for a production-based board. And we have some crud around our PP3V42 generator. This is our SMC switch, and it looks like this component is just completely burned, so we're going to be replacing that. The part that I'm not going to have fun with is our SMC. Looks like it's got a lot of junk around it, so we may have to clean that up, re-hot it. This is our backlight area, looks pretty bad. I think this is a 3.3 mux. I need to look back into that. And let's see, what else do we have going on here? BIOS looks like there may have been some moisture at one point, but it didn't get there. There's some rice. Looks like they tried to use rice to dry out the computer. Alright, so that's enough for me to see for now. So before we even test our power rails, I'm going to go ahead and remove this JTAG. How many more seconds? I got about another minute on my ultrasonic cleaner over there from previous repair. And let's get to removing this. So what I like to do, I like to heat up the JTAG and use some tweezers and go back and forth with my tweezers to heat it up. So I'm just heating it up and taking my tweezers and just running down the pads. For some reason, Apple decided to leave the SPI JTAG connector on the boards, and there's probably a really good reason. Maybe in the factory they have a way to repair the boards. Maybe they can reprogram the BIOSes, or even just change the serial number by plugging in here. But Apple's never going to touch this board again. Not only was it liquid damage, but it's already been replaced. Looks like someone else has already replaced this board. Alright, so we're getting there. Alright, off with you. That came off pretty smooth using that method. Alright, I'm gonna have to time out for a second because my ultrasonic cleaner just finished cleaning our last repair. I apologize, it's about to get very loud. And we're back. So we've gone ahead and we've removed that. Let's check around our SMC reset. So you can see there's a predominant black pin right here. So before we were getting 0.01, which typically means our PM Sleep S4 L line is missing, and that would make sense if our PP3V42 or our SMC reset was bad. So now we have fan spin. I'm getting booting voltage, but I wasn't getting any light. There we are. All right, let me show you real quick. It looks like that fixed the majority of our issue. So here's our board. And we got green light and fan spin. Let's see if it turns off and back on. All right, so it's off. It's gonna turn on again. Turn off one more time. And then turn on. So that is a successfully working MacBook. Yep. This one's booting up all the way now. But we're not quite done. One thing I noticed when this one, we're definitely going to take care of this SMC reset. This looked pretty gross. So let's pull up our schematic. Really don't know what this board is, but you know what? This one was liquid damaged. It's already out of warranty. We're going to remove this because this is either going to be a 00165 or 820 or 820, is it 3474? I might be wrong. I should know it. We work on these all the time. Alright, it is a 3437. Had the right numbers, just in the wrong order. Okay. We don't need the warranty sticker anymore because it's liquid damage. Whoever it was with, it's out of warranty. Back. Let's make it look a little better. Let's remove this with some acetone. It's like that warranty sticker never existed. Except for all the spots where it existed. Okay, so let's grab a donor board out of the back. Okay, so it looks like all the 820s, 3437s that I have are missing a couple of components. So I'm going to go with the 820-00165. That board is the closest board to what we're working on, and most of the parts are compatible. Alright, so we're definitely going to replace the driver. What about these components next to it? So for that, we're going to use a 820. So let's pull up on our schematic here. 820-3437. And here's our capacitor around our SMC reset. Come on. All right, so let's look around this here and see what we're dealing with. The first thing is we got a capacitor that looks like garbage. But it's not shorted. Okay. How about you? We got a resistor right here. That's reading basically 0 ohms. And what are we supposed to be getting? So that one is 5127. 5127 is basically 0, so that's fine. And what else do we have? That's okay. And that's alright. So, I'm just going to replace the driver itself. I'm sure cleaning the driver would fix the issue, but this one's already having issues with whenever they said before this happened, whenever they got the they pressed the power button, the entire computer would just shut off. And that typically means that the computer is doing an SMC reset. This is our SMC driver. And this could very well be related. Actually, I mean, after touching up the connection, everything looks perfectly fine. Curious if they've already had liquid damage before. And this is just the second time. I'm going to waste a little bit of time here. Probably shouldn't be doing that, but could it be because of all this stuff down here too? And this all looks pretty bad. Yeah, this could definitely be one reason why they were having power issues. Okay, so there's a couple of parts here that look very questionable that may need to be replaced. But let's just replace that driver. They're having some weird issues with the SMC just restarting anyways. Now, let's remove this. Well, that's right, I was still using a soft temperature from earlier. Come on, buddy, let's see if we can get this taken care of tonight. That way we might be able to jump on an audio IC before the end of the night. And just wick up the old solder. Alright, so that is prepped and ready to go. So now let's take this one from our donor board. I'm gonna be honest, I don't like the way that one looks on our donor board. I'll be back. Alright, we got one that looks a little bit better. A lot better, actually. So as mentioned before, they were having issues where when they pressed the power button, it would make the computer completely shut off. Like instantly, it would do a SMC reset. And the keyboard has to talk to the trackpad, which then talks to the logic board via an IPD cable, and then makes its way here to the SMC reset. So the SMC reset had a lot of corrosion around it, so we're just going to replace this first. If that doesn't fix the issue, we're going to look into the trackpad and see what's going on there. I didn't put my heat mat down, So I'm starting to make this mat that I'm currently on bubble up. Okay, now we're going to touch up those edges with our micro pencil. Whew. I'll be right back. Our eye was parched. Let's see, what kind of royalty-free music can we find right now? Let's do 3 hours of relaxing guitar music. Instrumental music, calming music, soft music, sleep music, guitar music. I don't even know what it sounds like. Cool. I'll go with that. That sounds nice. Okay, so I've addressed our SMC reset. Oh, this is corroded, but the computer does boot up. Let's take kind of a brief look around the SMC and see what we're dealing with here. Because there are some parts that I just don't like the way they look. Alright, so here's our SMC U5000. And our PP3P4 2_G3 definitely looked pretty bad. Let's see what the rating of this resistor is. It is 100 kiloohms. Let's see if we get 100 kiloohms on our multimeter. We get 99.9100. Believe it or not, that is actually okay. What about this resistor? This resistor we get 10, which sounds normal to me. Let's take a look on our schematic. Has R5193. R5193 is a 10 kiloohm resistor. Cool. Alright, we got these capacitors over here on the left side. That look pretty rough. As well as, it looks like maybe another resistor. Let's take a look. Alright, so these are PP3 42 G3 hot, which we know is not shorted since it boots up. So these capacitors, believe it or not, they are okay. What about our SMC TMS? The R5177. That is a 10 kilo ohm resistor. Do we get 10 kilo ohms on our microscope? On our multimeter? Our microscope doesn't measure anything. We get 10 kilo ohms. So, despite these components looking awfully oxidized, believe it or not, their ratings are still perfectly normal. So these don't need to be replaced, which would explain why this turned on just fine. Because they're just dirty. Now, we can touch them up. We can add some more solder, just so that it doesn't oxidize as quickly. I like to do is get the micro pencil and just touch up each side at a time. Our capacitors look so much better. So much prettier. Remove some of the oxidation on this resistor. That looks fine. Now what about the first one that we measured? Awesome. Put my hand in a big blob of flux. I realize that it is 11:45 here, so for those of you who are watching the live stream, I'm going to try to use my calm nighttime voice. Don't want to disturb anyone that's trying to sleep. Once again, we do have the eclectic sounds, the soothing sounds of the relaxing 3-hour guitar stream. Just look at this. There's a kitty up top. That's how you know it's relaxing. 3-hour relaxing guitar music, instrumental music, calming music, soft music, sleep music by Cat Trumpet. I hope you all enjoy. Okay. This little switch, assuming that's a switch, it looks pretty rough. It looks like it is a CPU thermal MOSFET. So that wouldn't have anything to do with the described issue of the random SMC shutdown. But what would be R5100. R5100 is a 100 kilo ohm resistor. Let's see if it is reading 100 kilo ohms. Coulombs. It is not. In fact, nope, it is. Sorry. I was touching the other capacitor to the left of it. We are getting 100 kilo ohms. So everything is fine there. I'm not really too concerned about our BIOS or SPI. I'm a little concerned about this area. What is this? I think it's a 3.3 volt mux. U3210. U3210 is, yep, 3.3 HV power mux. And it looks like it powers Thunderbolt. If I had to assume, Thunderbolt power switch. So this is going to be Thunderbolt. So we will need to test Thunderbolt afterwards, see if this is actually working. Thunderbolt takes a lot of power too. So we're going to clean it up. We'll touch it up with some solder. And we will need to test it out afterwards to make sure it still works. I think it's fine. That is the second time that I have put my flux on my microscope LEDs. Turn back on our micro pencil. We don't use it for too long, it will turn itself off. Not only is it energy efficient, it is OSHA compliant. Alright, then this is going to be our backlight circuit. Those balls look perfectly fine. So it looks like the main issue we had here is definitely JTAG related. Alright, I think that is a successful repair. Let's go ahead and put our board back into our logic. Not our logic board. Let's put our board back into our housing and see if this is going to turn on. Okay, I thought we were getting a little bit of lag there. Let's change our preference so that we can see a little bit more. Zoom out. Soothing guitar music. Let's go halfway. We are almost hour 2 into this live stream. So the rate that I'm going is 2 hours or an hour a board repair. I'd like to be a little bit more efficient than that. So for this one, I'm gonna test it out we're going to then do a test just to make sure that Thunderbolt works, that the display works, the computer itself works. What was the second thing? Completely slipped my mind. I also want to make sure. What do I want to make sure? It's getting late. Keyboard. That's it. I want to make sure that the power button is working again on the keyboard now that we have replaced our SMC reset driver. And we can even test all that out without having to put our solid state in. You know what, let's go back to zooming out a little bit more. Okay. So, let's see if this one boots up. We have booting power, booting amperage. Alright, should be turning on any second. So the screen just went black. I'm holding option so we can option boot. So you can see we have the connect to Wi-Fi and there's no solid state installed, so this one is not going to show a hard drive. Let's see if this instantly dies. Nope, it is still staying on. Nope, may have spoke a little too soon. Let's see. Alright, so it's on. Hit the power button once, and it's okay. Hit it one more time. It's still okay. So I believe that we fixed the SMC reset issue. Now, I'm not getting any light though right here on our MagSafe. There we are. I think it's just because we have it hooked up to our DC power supply. Just to make sure, let's hit the power button, see what happens. It's still on. Ooh. That was just the battery. Just because we don't have it screwed in the moment. Alright, so this one, we're going to give it a probably should go ahead and test out to see if the Thunderbolt is working. So for that, what I can do is just remove the display itself, the EDP cable right here. I'm going to grab an adapter. I already have an HDMI cable hooked up to a television I have right here. With the EDP connector completely removed or just not plugged in, and we have an external display, the computer will acknowledge the external display, in this case it's a television, to be the sole monitor. So, let's get this to turn on. We'll option boot. I need my TV remote so I can change the channel, the input. Alright, the computer just turned on. And the television's saying unsupported mode. So it looks like it doesn't like having the... Make sure we can plug that in all the way. I think there is some rice in the Thunderbolt port. I kid you not, I think there is some rice in the Thunderbolt port that is preventing it from making a solid connection. There is rice in the Thunderbolt port, preventing it from making a solid connection. So, it's going to get loud for a second. I apologize in advance. It still feels like there's a little bit of rice on one side of the port. Once more, apologize. Let's see if we can put it in now. It looks a lot better. This time, what I'm going to attempt to do is install the customer solid state. Have the external monitor hooked up at the same time. And see if we get any display now. And I'm just going to keep it in this camera just to not show their information. I'll let this boot a couple of times. Not what I was expecting. It's booting into Windows. Okay. Let's try that one more time. This time we're going to option boot. I want to boot into Mac OS. I admire the fact that there's Windows 10 on here. That's not for the faint of heart. And we're booting for our third time, so it's turning on now. Man, my hair is looking shaggy lately. Alright, here we are. Now let's boot into Macintosh HD. I just realized. Actually, I'm not gonna say it. Of course, it's not their password. Okay. I just want to know if your Thunderbolt's working. That's all I want to know. I'm not sure if I got all the rice out. I scooped out as much as I could. Okay, so my television here just keeps saying unsupported mode. I'm going to say it's a combination of two. The 3.3 volt mux for the Thunderbolt looked really bad, and there also looks like there is literally some rice inside of this MacBook. So I'm going to replace that mux before we give this one an ultrasonic cleaning. So we're almost done with this one. We just have an extra step we should take care of. At least we know that our backlight works. That was something that looked a little gross as well. Alright, so let's replace this. Let's turn up our temperature a little bit more. We have a giant ground pad underneath this Thunderbolt power supply. keep looking up to see the microscope camera and realizing how bad my posture is. We're right next to a chiropractor, and they gave me a lot of slack, no pun intended. Alright, so what I did there is I just touched a ground pad to make it melt a lot faster. Actually, no, I didn't touch a ground pad, but I touched a pad nonetheless to make it move quicker. And then what I'm going to do before we actually replace the IC is I want to measure to see if there's any obvious signs of shorts. Because the Thunderbolt takes a lot of power, 3.3 volts. It can escalate pretty quickly. There's actually a lot of ground pins on this one. Okay, so all the grounds are ground and everything else is not grounded. Okay, we will need our donor board again to pull off the 3.3 volt power supply. So this one's a CD3211, which is for Thunderbolt 2. Now on the newer models I use CD3215. And that's for the Thunderbolt 3, which is also a USB-C connection. And there's only one of these in this MacBook. Which makes sense, there's only one Thunderbolt. In the new MacBooks, there is a CD3215 for each USB-C that you have. So for the 12-inch MacBook, there's one USB-C. So there's one CD3215. There's two on the A1708s, which is the non-touch bar 13-inch MacBook Pro. But there's four on the A1706, which is the touch bar MacBook Pro. And then there's two on the new, what was it, 1932 or 1923? It's one of those numbers. Those are the numbers, just probably not in the right order, but MacBook Air. There's two on there, four on the 15-inch, and then the new MacBook Pros have four. I think what I'm going to have to do to help my posture, my tables, they're too high, but my microscope, it's too low. And it's because I have a Barlow lens on here. I think I have the 0.7 Barlow lens. but I seem to work better with my 0.5 Barlow lens. I don't know if it's this type of microscope, but I really don't have that much working space. I only have maybe 4 or 5 inches of working space. Maybe I just got a bad Barlow lens, but everyone talks about how great the 0.7 Barlow lens is. And I'm sure it's a great lens. I don't know if I just got like a knockoff one. Oops. Okay, let's see. The orientation of it was this. But it seems like I actually have a lot more working room with this, the 0.5 Barlow lens. I will say the 0.7 Barlow lens is nice because it is closer, which allows me to do trace work for like iPhones. So for instance, I'm not going to do it tonight. I said I was, but it's getting late. I do have one more MacBook I at least want to take care of, but I have an iPhone audio IC repair that the 0.5 Barlow lens is perfect for, because I can see very well inside of the phone and light up my traces. Okay. And just like before, we will take our micro pencil knife tip, kind of just touch up those edges. Because I love what I do, but I don't want this to affect me in the long run. 15 years from now, I don't want to have like chronic neck pain. All because I love doing board repair. I loved it too much. Alright, let's see if we have Thunderbolt after that. And if not, then I'm just going to go ahead and put it on the back burner and finish it up in the morning, just start working on another repair. But I feel like that was it. I think that's all this one really needed for that. And you know what? We don't even need to hook up our screen. We can just hook up our board itself and then plug in our Thunderbolt adapter to HDMI. Speaking of which, where is my Thunderbolt adapter? It's getting late, I already put it up, that's why. Yeah, there's still some junk in here. It's making a connection though. And hook up the power supply. Fan spin, and it's going to spin 3 times until it fully boots up. Okay, should boot up now. And now it looks like we're getting some sort of signal put out. Let's see if the television actually talks. Okay. And it's booting up. We are getting, it looks like their startup disk is Windows, so we are getting a Windows logo. Cool. So Thunderbolt does work. This one just needs to be ultrasonic cleaned now. Alright, so this one is a successful repair. We did have a missing Thunderbolt, however we were able to fix that just by replacing the Thunderbolt 3.3 HV mux. So this one's just dirty. It needs to be cleaned, put in the ultrasonic cleaner. And let's see if I can get one more done before we get out of here tonight. I will say it's starting to hit me though. I am getting very, very sleepy. I've been here since 9:45 a.m. Let's put the music back on my side. Should still be playing in the OBS. Awesome. Just gotta love that soothing 3 hours of sleepy guitar. I actually listen to this stuff when I work. To be honest, I almost can't not listen to music when working. Alright. What we need to do before we put in the ultrasonic cleaner is we're going to have to pop off this metal shield right here. That way the bubbles from our ultrasonic cleaner can go underneath all the components and kind of push out any gunk that might be hiding around. So, well, thank you, board. Thank the donor board. And we will reassemble all this in the morning. And this one is going in the ultrasonic cleaner. Okay. Hi, today we have ourselves another MacBook Air. This one's a A1466. This one's in here for liquid damage. Let's see what year this one is. If I can remember correctly, this one didn't really get that much liquid on it, but it's enough corrosion to where we really want to address the issue. So this one here is an 820-00165. Ooh. What is going on here with my cable? There we are. Alright. So yeah, this one here is a 820-00165, which is either 2015 or 2017. And if I remember correctly, this one actually works, but there's just a lot of corrosion on here that it needs to still be addressed. What I was most concerned on this one is whenever you hit the power button, the whole entire computer completely shuts off. So we have a green light, our power supply. See, we have fan spin, power supply is showing booting voltage. But let me show you right here what I'm talking about. So here is the power switch, or the MagSafe, and when I hit the power button, it changes from orange to green. So that means that something here is doing an SMC reset. If I look at the board, around this area, we have our SMC reset driver. And it looks like something here is bad. So this could be one of the reasons why, whenever you hit the power button, this flips off as well, or it turns off the entire computer. Now, another thing is how the power button or the SMC reset works is the keyboard has to go through the trackpad, which then talks to the logic board via an IPD cable. So if we look at our trackpad connection here, I don't see any signs of corrosion. Don't see any signs at all. Our IPD cable looks fine from here, but let's pull it out just to inspect it. There is some corrosion right there on our IPD cable. So that could be actually one of the reasons why this is turning off. We may have to replace it, but let's just see what just scraping off this gunk will do. And our ultrasonic cleaner has just finished cleaning one part of a board. I'm gonna have to flip it over and clean the other side. But let's put this back in and see what is going on. See if maybe the IPD cable is the reason why whenever we hit the power button, the entire computer will do an SMC reset. If not, then we still will have to look at the SMC driver, since it looks like it's got a lot of corrosion on it. So we have a green light up here. Orange light. We can hit the power button. It goes to a green light. So, despite the corrosion on the IPD cable, that didn't resolve the issue. Being that we have a lot of corrosion on the SMC reset, I'm going to say we need to address that. Now, I'm going to take a time out here, just so I can go ahead and flip a board. And we're back. So let's start off by removing the board. So we have our logic board pulled out. Let's go ahead and zoom in more. Okay. So as far as corrosion goes, we definitely have some stuff around our SMC. Looks like some around our backlight driver. Ooh. Sorry, thought I was about to sneeze. Let's take a further look underneath our microscope. So we had previously just worked on a 820-3437. This one's an 820-00165. It's a very similar board, but we just need to pull out our schematics. Let's see. And Flex Board View has finally stopped working. Let's open that back up, see what's going on. Okay, so where we have a lot of corrosion right now, right here underneath our microscope, it's going to be next to, looks like this giant coil, which is part of our, let's see, TBT, that's probably Thunderbolt Boost FET, if I had to assume, PP5E_S3_U6210, so this is going to be part of an S3 line that is 5 volts, and then U3090, that also had a good bit of corrosion around it. Let's see what that is. According to that, that is our Thunderbolt 15 volt boost regulator. So, just like a previous repair we done not that long ago, this one may also need a Thunderbolt repair. And I will just have to time out again. My board has just finished cleaning. Let me just go ahead and dry it off. Alright, and we're back. And that logic board is all clean, so now let's get back to this one on hand. Alright, so this one does boot up, but as mentioned, there's a great deal of corrosion. Honestly, the fact that this one even turns on is amazing. Let me change over my microscope camera. I didn't realize I had that off. So first thing I notice is that the backlight for the backlight on the LCD, I'm sorry, is really bad. Like, all of this looks really, really bad, but it boots up. Just whenever you hit the power button, it just does an SMC reset. Like even right here, the fuse for PP bus, that looks really bad. But if we put this into continuity, this is probably going to beep normally. Yeah, so PP bus is fine. Our backlight circuit looked fine. Like all this is, let's see, this is going to be right underneath our PP3V42 circuit. But let's check and see what this is. Because I don't like the way it looks, but it works. And it's very possible just cleaning it is going to fix it. So this is going to be our PPDCN G3 hot, which is present. This whole circuit, what it does is it takes our MagSafe charger, runs all the way through here, goes through a diode that helps us distinguish if we're going to be using battery power or DC power from the MagSafe, and then it creates our PP3V42 underscore G3 hot, which then powers the rest of the system. And this is how it looks like. But it works. Despite all the grime that is here, this boots up. So, what we're going to do is just, Lewis Rossman says it the best, and we're going to do some janitor work. Really, we're just going to be cleaning up things. Like all the stuff's here, just the connections, they're bad. Okay, let's see what else. We have a lot of stuff around our CPU high side ints. Pretty sure that's what all that is. Like this, like for instance, this capacitor looks completely blown out, but no, it's fine. And that's part of, I think that's part of PP bus. That might actually be part of our CPU. But, I mean, it boots up, so the CPU's not dead. Our clock. Ah, don't touch your face. Our clock looks bad. But, without a clock, it wouldn't have booted up. And then around our SMC looks pretty rough too. In fact, we actually have corrosion underneath our SMC. That could be one of the reasons that this does a reset. This might not be the first time this has ever been wet. I don't think we need to reflow the SMC. Just need to give it a good cleaning. Alright, let's see. So we're around our Thunderbolt mux. This capacitor looks rough. Yeah, this is our 15 volt Thunderbolt boost circuit. Let's see if this is shorted. It is not. It is not shorted. But our Thunderbolt's probably really rough. And let's see, is there anything else? Ooh, this looks important. Alright, let's take a look at that on our schematic. That worries me. This whole part of the board always worries me. PP3V3SO, which is present because that's needed in order to power on. So these would be fine, and they are capacitors. And they are not shorted. Even this looks rough. And this is probably part of RAM. No, it's our PP3V42_G3 hop, which is present. So despite all the really bad corrosion and oxidation, I apologize for those who are using headphones. I tried catching it. My reflexes are horrible right now. It is 12:40 a.m. Alright, let's see what's going on. Okay, I just kind of lost everything for a moment there. Okay. We are back. So, let's just get to cleaning up. We want to remove as much corrosion as possible so this doesn't oxidize in the long run. So it's in focus for me. It's in focus for the microscope. No. Let's get to it. I don't like the J tags. We're gonna remove these. These are good for killing the SPI. Get out of here. Alright, that's gone. That's one less thing to have to worry about. This area, honestly, I'm surprised that the entire machine even boots up. a very important area, but the computer doesn't care. If this computer was an animal, this specific one would be a honey badger. I know that joke is outdated, but this computer does not care. It took what was thrown at it and spit it back out like it was no one's business. Okay, that looks significantly better down there. Alright, so this is part of our IPD cable, which is connected to our trackpad, which eventually makes its way to the keyboard. Let's see if this has anything to do with our SMC. What is this? No, that's just PPDCN charger. Yeah, so that's fine. I don't like that capacitor. We're going to replace that. Yeah, I definitely don't like this capacitor. It's only a matter of time until it cracks. That's probably a little bit too much flux for this capacitor, but it'll get the job done. That looks significantly better. I feel a lot more confident with having that there. Okay, let's see what else we can tune up. So this is going to be our Thunderbolt boost, which may or may not be dead. Let's see if there's any obvious signs of a shortage. I think this is a resistor. It is resisting. This looks like a capacitor. It is capaciting. No. Let's give this one a cleaning and touch it up with some solder. We may have to end up replacing this one. Let's see, what else do we have around here? Oh yes, the backlight circuit. Let's see if our fuse here is still working. Yep, our fuse is still fine. And then just to make sure that we don't have a short to ground. Aha, we do. Wait, that's not a short to ground. I think that's just ground. Yep. Let me confirm. Pretty sure. It's just there's so much stuff in the way, it's kind of hard to see. Yeah, first pin's ground, so that's normal. Wow. Let's go ahead and remove this EMI shield while we're at it. Okay. Cool. Okay, here's our SMC. So this is the one that's in question. Let's see. so it's U5110. What we want to do is make sure that these measurements around here are fine. I get some big blobs of flux all over my tools over here. Alright, so first thing is, this is a capacitor. It is capacitating. This resistor is basically 0, which is normal. This is reading 2.3 kiloohms. That's a capacitor. Alright, so since we're having issues anyways with our SMC, we'll just go ahead and replace that. So I believe I have an SMC right here. Yes. Well, it's not an SMC, I'm sorry, let me take that back. Our SMC reset. This basically is the power switch for the entire MacBook. Getting a little bit of lag. Looks like we're getting a little bit of latency now. Yeah, we're 3 hours into our our stream now, so we are definitely getting a lot in latency. It's either that or OBS just doesn't know how to handle itself anymore. Yeah, that's exactly what's going on. Okay. So that has now been replaced. That may or may not have resolved our SMC issue. Our SMC reset issue. Okay, let's look around our backlight area. Yeah, things are starting to get all choppy now, so I gotta finish this one up. Let's look around here, see what's going on. So we're on the back side of the board now, around our system management controller. And we have a couple of capacitors and resistors. So SMC DC ions is there? None of this really looks related towards our power switch for our SMC. Okay. Just like everything else, let's do some cleaning. Okay. Got a little bit of crud. And that crud is PP3V3S5 SMC VDDA, which is basically power supply for the SMC, which SMC is turning on, so that is not bad. Now this is going to be part of our power switch, and this is going to be a 100 kilo ohm resistor. Well, let's see what we get. We get 100 kiloohms, so that's fine. All of that is okay. Next to it's just a couple of capacitors. Okay. Now, we already talked about our Thunderbolt earlier. Thunderbolt is working. And that was our backlight, which is working. And really what we want to take a look at now... Oh, well, let's take care of our clock. The clock's just got a little bit of gunk around it. Might as well tune it up some. Oh no, just got flux on my screwdriver. I don't know what it is about a new batch of Amtech Flux. Maybe I'm just using my plunger wrong, but it seems like whenever I get a new batch, it just constantly leaks everywhere. Okay, so let's go over here. And we said that these were a couple of capacitors for the PP3B42. Let's see, this one looks bad. This one looks okay, but yeah, this one looks bad. Let's go ahead and replace these. Looks like there's a test pad hiding underneath here. You know what? It would help if my tweezers were plugged in. Oh yeah, this stream's starting to get really choppy now. We'll be done with it soon enough. Yeah, I'm glad that we're replacing these, because you can barely even see the pads. Okay. Now let's take those capacitors from our donor board. Okay, those look a lot better. And I think we're done. I think those were the last components that really looked bad. Well, there's this. Also part of our PP3V42 G3 hot. So, we'll keep the tweezers plugged in, why not? Okay. Ooh, almost forgot this area. What is this? Let's check and see what this is. It's like U7100. U7100 is our ISL, which is our battery charger. Let's see what that MOSFET does. That MOSFET is U5660. U5660 is responsible for its high side gain PNN. With 100 milliamp battery current, will have 10.2 millivolt difference going into sense. Debug sensors. Okay. So this is going to deal with debugging, and it looks like specifically this is battery related. In battery discharge scenario, negative voltage will be present on plus negative pins with I and A. Output voltage decreasing 3.3 with increasing discharge current. And let's just make sure that's not shorted in any way. Stop. You look fine. Okay. Are we officially done? Okay, we're good. So, I want to know if doing any of that had resolved the power button in SMC reset. Okay, so that is all the minimum we need for this to turn on. So let's see if we get the same thing again. So we got a green light, we have an orange light, hit the power button. When I hit the power button, it just stays on an orange light. So it doesn't look like it's doing an SMC reset. Actually, at the same time, it's not booting up. What's going on here? It was fluctuating in voltage. It's good that's not taking doing an SMC reset anymore, but that was weird. Yep, we are plugged in correctly. No, no more fan spin. So something's fluctuating here. Yeah, it's acting like it's trying to turn on, but it's never actually making it. let's see. What happened here? First thing I want to check is going to be our SMC reset, because we went ahead and we replaced that. Make sure that this is getting the proper power it needs to turn on. Okay. So we're getting 3.42 going into it. Let's check and see what's coming out of it on pin 5. .3, which is correct. And let's see what's coming out of pin 8, which goes to our SMC. Staying at a nice solid 3.3. Oh, sorry, you can't see what I'm working on. Okay. Make sure that the SMC on off signal. No, I mean SMC reset is working like it needs to. So that's not the issue. Interesting. So while cleaning, we actually had either knocked something off or we jarred whatever corrosion was holding it just enough together to keep this from working. Let's see if we can solve that issue. Now I feel even better, because it seemed like the majority of this was just cleaning up. And now we've just proven that if we didn't address a certain issue, this would definitely come back. If I had to guess, we don't. That's just it. We just don't guess. But something's quickly turning on and turning back off. Turning on, turning off. Let's take a look at our PP3V42 generator. Alright, so at the end of the circuit we should be getting 3.42. And let me just look at the schematic to see where exactly we should be probing. Okay, yeah, so behind this coil right here of 2, we should be getting 3.4.2. And on that coil, we're getting 3.4, but it's fluctuating. So it's like turning on, off. Okay, let's kind of look at our charger AC. That's fluctuating. So something is fluctuating our power. Curious if we have a short now. Let's find out. Okay, nothing there. One spot that did look very suspicious that we probably should have replaced anyways is this thing. That looks really bad. So, let's go ahead and take care of it. For this, to make it a little easier to remove, let's switch over to our tweezers again. Okay, I see exactly what's going on here. But this MOSFET looked bad anyway, so we're replacing it. Okay, I'll show you exactly where I messed up. This is our ISL, and I have bridged two connections right there. And let's just examine to see what that is. If I had to assume, that's going to be current sensing. Well, let me pull up here on our schematic, our board view. The tube that we have right here is going to be charger AC in on pin 3. Nope, that's not right. Hold on. It's going to be charger iComp and charger VRQ, probably frequency, V frequency. Well, those aren't supposed to be touching each other. Let's see if just by simply breaking that joint, if it'll boot. If not, we'll just end up replacing it. Thank you, donor board. Okay. So while I have this MagSafe already hooked up, let's see if it's going to turn on now. And fan spin. Cool. So it's booting up. That was indeed the issue. That part of iComp and V frequency, I'm assuming that's what that is, being hooked up, were preventing the computer from booting up normally. So that was an oversight on my part. Now, let's see what happens when we put everything back. Because the main thing I wanted to test out before I got out of here for the night is this going to do an SMC reboot? Come on, man. You can't be that tired. You should still be able to hook up a simple connect cable. Alright. So, let's see if this has fixed our issue. So, let's boot this up. Man, the saturation on this is real. Alright, we have orange light. Press the button. And it's no longer wanting to do an SMC reset. So, it looks like we have resolved that issue. And just to show you that this does boot up. That is a fully working MacBook. Yep, so this one just needs to be ultrasonic clean before I get on out of here, and I'll worry about assembling this back together. So, thank you so much for taking the time and spending the evening with me with iRevive After Hours. I'm just kidding, it's not actually going to be a real thing, but I'm exhausted, and fortunately, we were able to do 3 repairs, which makes up for the one repair that's irreparable that took 10 hours to finally get to that stopping point. So, thank you, as always, and I'll see you in the next one.